We're going to be looking at limits with tables and specifically vertical asymptotes. So some of this is actually kind of based off of the graph, but we've already talked about limits and graphing. So I want to give you another option of how you could find those limits using tables. Before we get to that, I want to talk about a vertical asymptote. Remember that if I have a graph that looks like this, something like this, this right here is my vertical asymptote. Sorry, it just kind of paused on me there. And then, of course, it transferred over to my other screen. So sorry for that dead air. I'm going to have to redo this real quick and get it adjusted before moving on. Like I said, sorry about that. It's like it disconnected from my laptop to the smart board. So anyway, like I was saying, the vertical asymptote is where the graph is approaching, but it never actually touches. It's kind of like a gap. In this situation, you can see that one's going negative and one's going positive. You could have it where they're both going in the same direction. It just kind of depends on the graph. But just note, this is where our vertical asymptote occurs. Generally speaking, if we have a function, and I should just move on to the next example. So let's say that my function f of x is 1 over x plus 2. Okay, so they're going to ask you, where is the vertical asymptote, and then what's the limit as this approaches this and this is approaching this with a table. Okay, so vertical asymptote. Vertical asymptote is going to occur wherever the denominator equals 0. So in this situation, I always just take my denominator, set it equal to 0, solve for x. So my vertical asymptote is going to occur at -2. However, this is not always the case in case you have factorization that you have to do in the numerator, in which you can cancel stuff out, and then your vertical asymptote no longer exists for that point. It's a hole, which we talked about in a previous lesson. Anyway, vertical asymptote occurs at x equals -2. So then we're going to ask, okay, what's the limit as x approaches -2 from the right of f of x? And this is where tables come into play. And with those tables, you need to use Desmos. Now, normally I tell you, Desmos, just graph it. You technically could, but however, like I said, you need to learn how to use the table feature on Desmos. So we go to Desmos. There's this little plus sign here. Sorry, shrink that up because I don't really need all of that space. Plus sign, and I'm going to add a table. So I know my point of interest is at that -2. So I need to find values that are close to -2, get to -2, and then go on the other side. So here's what I mean. I'm going to have such as -2.1, -2.09, -2.08, and so forth. But I'm going to actually shrink this up a little bit and go a little bit smaller. Ooh, too many decimals there, my bad. So you can see where I'm going with this. So 2.001, 2.01, 2.03, 2.06, 2.09. So I'm just kind of getting a value there at around x. I'm getting values that are a little bit above it and a little bit below it. Now this y1 doesn't know how to calculate anything, so I'm actually going to change that out with my function. So this is 1 divided by, now that x, normally we would just type in x plus 2 and call it a day. However, it doesn't know what x you're referring to. See how this table is listed as x1? So you have to label this as x1 plus 2. And if you notice here, it gives me values. And those values are going to help me. And notice I actually did this wrong because I was thinking positive 2. And now it's really mad at me. So this would be negative 1.99, negative 1.90, negative 1.85 or something. So I actually don't need these values. Those did not help me because I was not thinking. That is my fault. I am sorry. So we're just going to leave those blank. My fault. So you can see here that at negative 2, I'm to the left and to the right of negative 2, very close to it. I'm sorry again that I screwed up my table there. But this is something good to see. So on the left side of that negative 2, I can see that these numbers here are going towards negative infinity. These numbers on the right side are going to positive infinity. So remember, if I'm going from the left, I'm coming to the value. If I'm coming from the right, again, I'm going to the value. Where's it going? Well, I can see 6.666 to 10 to 100. That number is going up, so it's going towards infinity. On the red, I can see my numbers getting smaller and smaller in the negatives. So that's going towards negative infinity. So using the table, without even using the graph, I can see what's actually occurring. So as the limit approaches negative 2 from the right, it was going towards positive infinity. And we just had our graph. As the limit is approaching negative 2 from the left, that was going towards negative infinity. And that's all based off of that table. Now, there are times where you will be given the table and then you'll be asked to find the function. So a little bit of background on that. You wouldn't have then this part up here. You wouldn't even know what that is. And then you're supposed to figure out what is the value, okay? Or what is the function. So looking at this, I can see I'm undefined there. So I know it's going to be an x plus 2 situation divided by. Now that top part I might not necessarily know, but use those points that they give you in the table to kind of give you an estimate, right? So I can see here, negative 2.1 is negative 10. Okay, so I have something over negative 2.1 plus 2 is supposed to equal negative 10. So I can go through and then solve maybe what that number is, or maybe it's a function that you can try to plug in and figure out. So that's how you're going to go work backwards if needed. There's some matching situations, so that's why I say that. But otherwise, the table is pretty helpful. Without even graphing, you can see what this function looks like. Now, graphing it obviously is going to be the way to go. I say that just because we've worked with graphing. Graphing's a lot easier to look at those numbers and see what's going on. If I had 1 over x plus 2, ta-da, there's my graph. I can see from the left it is going towards negative infinity here. As I'm approaching from the right, it's going towards positive infinity. So obviously easier to look at the graph, but I wanted to show you how to use tables and how those values could help you in order to figure out your limit.